how does water treatment affect your boiler's operation? We know it affects the longevity of the equipment. If we don't have oxygen scavengers, we don't blow down, we're going to overheat tubes or get pits in tubes. But one factor, TDS, or the corresponding conductivity, affects your boiler every day, whether you know it or not.
It's time for your weekly boiler tip.
So the way that conductivity and dissolved solids affects your boiler is we're either preventing carryover or we're allowing carryover. We've got a boiling level in here and there is foam on the top of it, because just like when you're boiling a pot of potatoes, we get bubbles that kind of stick and they can foam. On a boiler, we've got some devices that help prevent foam from being carried out. We call those dry boxes or steam separators. But the TDS or conductivity of your boiler is critical for that to be able to do the job. If you think about a boiler full of clean water, it's just like when you boil water before making spaghetti. That never boils over until you put the noodles in there. Then the starches and stuff coming into the water make those bubbles more stable, and you turn your back on it and it's boiling over. So in a boiler, we have a similar situation. As the conductivity, the dissolved solids comes up, bubbles become more stable, we're more likely to suck moisture with your steam out into the system. And the fact of the matter is, we need steam out in the system, not that water. So controlling conductivity helps control carryover. So how much is too much? Well, it depends. It always got to depend on something, right? In this case, it depends on the pressure rating of the boiler. The higher the pressure we run a boiler, the smaller the bubbles in a lot of cases. So that can help us. It actually is affected as well by how hard we pull steam from the boiler. If a boiler's running at a minimal load, we've got a lower velocity of steam leaving, and it's more difficult for that steam to carry the water with it. So there's actually a sliding scale on conductivity based on the pressure you're running the boiler. At really high pressure boilers, we've got to run extremely low conductivity. At lower pressure boilers, we might be tempted to run higher conductivity. So how do we actually know what that limit's going to be? Well, there's a couple things we want to think about. One is what pressure are we operating at? One is how hard are we pulling on the boiler? This same boiler, if it's idling all day, can handle higher conductivity than this boiler if it's running hard all day, because the harder we're running, the more propensity for carryover. So how do we know when too much is too much? We don't look at the boiler, we look at drip legs on the system. So here's a drip leg on the system. We can see the line going to the trap and back to the deaerator from here. But we've also got a drain on that. If we hook that up to a sample cooler, we can get a measurement of the conductivity of the water in that drip leg. And fun fact, steam condensate should have near zero conductivity because we're basically distilling that water. So if I get high conductivity readings out of that drip leg, that's telling me water from the boiler is ending up in the head. We can also take a sample of water at our feed tank. So the water coming out of our water softener is going to have a certain conductivity. We can measure that. We should measure that because we know that that's going to impact our feed water conductivity. We're also putting chemicals in it. So it may be that if we're running 100% makeup and we're using a lot of chemicals, we'll have 400 or 500 for our conductivity in the feed water. There's not really any way around that, except bring condensate back. If we're bringing back the majority of our condensate, the conductivity in the feed tank is actually going to be lower than our incoming water. And a rough estimate is if you take your makeup water source and you take your condensate, you can almost tell how much condensate you're getting back. You divide that out, and if you're half of your makeup water conductivity, you probably have about 50% condensate return. But if we see spikes in the conductivity on our tank at high demand periods, that's telling you that whatever the conductivity in our boiler is, it's too high. I got a saying, it's if in doubt, blow it out. If you're getting steam quality problems, we got to start with lower conductivity in the boiler to enable that to stay in the boiler.